Let's talk about indexes. So again, I talk a lot about queries being expensive. Another one is you want queries to be fast, right? So let's say you're doing like a pet adoption website and people ask for, I want to see all of the dogs, right? If you have 1 million pets in your pet adoption database, that could be quite slow because it's going to go read all of the objects or all the documents in your database, and it's going to filter for all the ones that have type dog on it. It'd be better if we had that indexed so that the database can basically take a shortcut. Instead of having to look at every single document in the database, it can say, just build me like a tree that allows me to go search for all of just the dogs in my database. So this is called an index. And this actually exists in all of the databases that we're going to talk about today, except Redis. So we'll be talking a lot about indexes today. So let's say db.pets.find name Fido. Okay? So I'm going to just search for all the pets named Fido in my database. It's fine, it works okay. I only have 10,000 items in my database, which for MongoDB is not that many. It's used to handling millions and perhaps even billions of records. But let's do a .explain on this. And we're going to ask for the execution stats. So this is actually going to pass back to you from Mongo and say, here's how I'm going to find that. So it does this, what's called an execution planner or a query planner. You'll hear those terms thrown around quite a bit. So the first thing it does is say, all right, here's the query that I'm looking for. I'm looking for name where it's equal to Fido. And then it has a winning plan. Sometimes a database will try multiple different strategies to try and figure out, okay, I can search this way, or I can search this way, or I can search this way. In this case, there's only one way to find it. It's going to do what's called a call scan. And this is your worst nightmare right here. Call scan is like worst case scenario. I'm going to look at literally every item in this, or every document in this collection to find all of your pets named Fido. This is not what you want to see. If this is a query that you run a lot, you need to index this so that you don't see call scan. If you run this like once a day, that's fine, right? Once a day you can take a performance hit, it doesn't really matter. But if you're running this 10 times a second, you need to index this yesterday. So this is the part that you want to be looking at here is the winning plan. And you can see here the call scan is exactly what you're trying to avoid. So here the execution stats, this is actually going to go through and tell you what it did, how long it took. And you can see here, this is, again, we have 9,644 items in the collection, and it looked at all 9,644 items in the collection. This is not what you want to see. So how can we fix that? Well, we're going to do that by creating an index. So the first thing we're going to do is we're going to say db.pets.create index name : 1. And what we're doing is we're creating a simple index on name, and that's it. Now, something else I probably need to throw out there, don't just log on to your server and say create index willy-nilly if you don't already have one. This is actually a fairly heavy procedure to do. So don't just do this in production. Like, this can cause downtime. This can be very expensive. Again, we're doing it for 9,600 and some odd items in a collection. Not that big a deal, but for 1 million, this could take down your entire app. All right. So now if we run that same query again, find Fido with execution stats, notice up here we're going to see stage fetch. This is what we want to see. This is much faster. This is much better. This is basically said, like, I found an index that uses, or that I can use to find whatever you're looking for. It goes way faster. So you can see here, it gives you a lot more information of how this index works. But keys examined, I'm trying to find the right one to point you at. So docs examined 964, that's the one that you don't want to see. So total docs examined here, 1070, right? That's significantly better. But I also think, if I remember correctly, dot count, I'm sorry, not dot count. If I say count here, that's actually the correct answer. That's how many dogs are actually, or sorry, that's how many pets are actually named Fido. So 1070 is the bare minimum. So it went significantly faster. It looked at significantly less documents. And if you've taken my data science, or not my data science, but my algorithms class, this actually builds a tree in memory so that whenever you're doing these queries, it's actually going in memory, so it's not writing to disk, and it's going through a tree rather than looking at every single item in the database. So this should give us some performance stats as well. Again, I'm on a pretty beefy MacBook Pro. How long did this take? This took 2 milliseconds. And let's see up here. How long did this one take? 4 milliseconds. So not that huge a difference, again, considering not that many items in this collection, and also it's on my MacBook, which really isn't doing really anything else right now. But even still, 50% query increase, not bad, right? We're not upset by that. So at any time as well, you can say db.pets.getIndexes. And you can see here, we have one on name. You will always have one in ID. ID is always indexed just by default. And yeah, that's how you do indexes. So you can do compound indexes. So let's say you're frequently querying by both maybe age and pet at the same time. You can actually make a compound index that uses both of those things. You kind of just have to understand the shape of your data that it needs to be in, and how you're going to query it. Normally I kind of wait a little bit to figure out what queries I want to do, or sorry, what indexes I want to do, and kind of see how I'm using the database and how the code is written, and then I'll go make indexes to kind of index those kind of hot code paths. Because if you have an index that's not doing anything, then it's just taking up space in memory. Yeah, don't have useless indexes as well. That's another good piece of advice, because it just wastes space and performance. Let's talk about something else. Let's talk about unique indexes. So right now, in our database, you can have, in fact, here's a good example, because I think I did this earlier. DB's index find index 10,000. Oh, no, okay. So I actually only have one item of index 10,000, but this index should be unique, right? No one should have the same index in this particular collection. So we want that to be unique. Or maybe you can imagine, like, maybe you're doing a users collection and you want the username to be unique, right? So you'd put a unique constraint on that particular field. You can do that with unique indexes. So what we're going to do is we're going to say db.pets.createIndex, and we're going to index, that's funny, index referring to this particular field in our collection, right? It's nothing special about the word index. And then all you have to do is you add another thing here and say, make sure it's unique. Okay. So I went and created a new index. It's on index. So now if I say db. That same one, that query will go much faster because it's not going to scan all of them. It actually goes directly to that particular thing. But the other interesting thing is I say db.pets.insert1, and I try to insert a index 10,000 like that. It's going to give me an error. It's going to say right there, duplicate error key, right? So it's actually not going to let me insert duplicate keys here. That's what that unique constraint allows me to do. Whereas before, it would have just happily accepted that right. Another useful thing about this is now index is indexed, right? The index is indexed. That's just kind of a necessary byproduct of doing a unique constraint, is it does have to index that.